lesson 11.1, it's going to be sketching square root functions. You should be on page 710. Again, note, I said sketching. So this would be a no calculator activity when I say sketching. Let's get our vocabulary out of the way first. A radical expression is an expression that contains a radical, such as a square root, cube root, or other root. So if you have a radical in the expression, it's called a radical expression. A radical function contains a radical expression with the independent variable in the radicand. So, for example, these things that I'm circling, these would both be examples of radical functions because they have a radical in it. The independent variable, which is always x, is inside the radical. So in other words, this gets us back to early in the year. You're going to take a value for x, you're going to plug it in the function box, and it's going to produce an output of y. What this is saying is the x value, what you're plugging in, is going to go inside the radical. That's what makes it a radical function. If a radical is a square root, then the function is called a square root function. So this is not a square root function because it has a cube root. So that's not a square root function, but this one is because it's a radical function that has a square root. So that gets the vocabulary out of the way. I would definitely get those in your notes. Let's talk about the parent function for a square root function. The most basic square root function in the family of all square root functions, called the parent square root function, is what you're seeing here. And the sketch of the parent square root function looks like the following. It's a half parabola that starts at 0, 0, and it opens sideways upward. So that's what a square root function looks like. It's a half parabola opening upward. All right? Before we get into sketching, there's more that we need to look at regarding this, which I'm going to show you right now. But again, this is the parent function. That's the most basic square root function you can have. Let's talk about how we sketch a square root function. To sketch a function in the form y equals a times square root x minus h plus k, you can follow these steps. Now, I'm actually going to write, these look more complex than what I think we need, so let's look at what I put here. Here are the two steps I would like you to follow. You see how there's an a in here. A tells us if the radical function opens up or down, and if it's stretched or shrinks. Doesn't that sound familiar? This is exactly what A told you with parabolas. So the A value in front doesn't tell you anything different than you already know. So that should make this a lot easier thinking about that. And now here's another thing. The H and K is exactly like vertex form quadratics. It gives you, I probably shouldn't call it the vertex, it gives you the starting point of this half parabola. I'm going to change that. This gives you the starting point. So I don't know that that point is actually called the vertex, but it's the starting point. So if you think about vertex form quadratics, here's your starting point. This tells you if this opens up or down. That's all you need to really know to sketch these things. Let's actually apply that in some practice right now. Let's try number 1. We want to sketch this function and identify its domain and range. And we want to compare this graph with the graph of the parent function. Now remember, the word compare, we got to compare two things. Where do they start and how do they open? So two sentences. So I wrote both functions down here that we're going to sketch and compare. So first of all, the parent function. Its vertex is at 0, 0. You might be asking, well, how can you tell? Well, remember, I see nothing here inside the radical, and I have nothing here. 0, 0 is my vertex. And A is 1, so this thing opens up, so my sketch would look like that. And let's label 2 other points. It's always good to label a couple other points. One point on the sketch I should label right now is the origin, 0, 0. Let's get 2 other points. Pick numbers that you can plug in for x that are perfect squares. It'll make your calculating easy. So if I plug in 1, which is a perfect square, the square root of 1 is 1, so I can label that point. And my next perfect square is 4. If I plug in 4, the square root of 4 gives me 2. That's an easy one. Now let's sketch this. Now, this sketch, it also opens at 0, 0 because you notice I have no number inside the radical and I have no number outside the radical. So there's my vertex. Same thing, 0, 0. But you notice how A is 2. So this definitely opens up, but it's also being stretched, which means this half parabola should look like it's higher up. Okay? Let's get a couple other points real quick. I want to use perfect squares because those are easy to calculate. So my first perfect square is 1. And now remember, we got to do this in proper order. A radical works like an exponent. I got to do the square root of 1 first, which is 1, and then multiply by 2, that's 2. So this is the point 1, 2. And then my next point, let's plug in 4 because that's a perfect square. The square root of 4 is 2, and 2 times 2 is 4. So when I plug those in here, I'm getting 1, 2, and 4, 4. Now I want you to notice something. Let me highlight. Look at the y values. Do you notice how the y value I'm circling is double the y value that I'm underlining in each case? 4 is double 2, 2 is double 1. Here's why it doubles, because the 2 in front. It's doubling everything. Okay? Now next, we need the domain and range of this function. They asked for that. The domain is what are the values for x in this thing. Well, you notice this, I'm going to use a red pen. This thing starts here and only goes to the right. So my domain would be x is greater than equal to 0 for the function I'm starring here. And now my range, this is asking what are the y values. Let me use a green pen this time. Do you notice how the lowest the function y equals 2 square root of x goes is here? That's the lowest it goes, and it just keeps on rising. So my range is y is greater than equal 0. Now I need to write 2 sentences comparing the functions. Let me do that. And there you go. Both functions start at 0, 0. So there's one sentence comparing the starting points. And here's my second sentence. Y equals 2 radical x is stretched compared to the parent function. So there's my sentences comparing these two. Let's also try number 3. Y equals square root of x minus 1. So I want to sketch both of these. So let's sketch the parent function first. Now the parent function is always going to be the same. It's going to start at 0, 0. It's going to do that half parabola opening up. And on that half parabola opening up, you know, the point 1, 1, and 4, 2 will always be there. Because think about it. If you plug in 1, the square root of 1 is 1. And if you plug in 4, the square root of 4 is 2. Okay, let's sketch this. Okay, the vertex of this. Now you notice there was no number, maybe I'll use a blue pen to highlight it, there was no number being subtracted in here, but then we had a minus 1 outside the radical. Can you see where I'm getting the 0, negative 1 for my, I shouldn't call it vertex, let me just call it my starting point. Okay, let's just erase that and call it the starting point, because it's not technically called a vertex. So 0, negative 1 would be my starting point. Okay, let me get a couple other points here. 2 other points. Well, if I plug in 1, this thing is going to work out to 0. So if I put a 1 in here, the square root of 1 is 1, and 1 minus 1 is 0. And then my next perfect square is a 4. If I plug a 4 in here, the square root of 4 would give me 2, and 2 minus 1 is 1. So there's 2 other points that I can quickly identify. And now let's write my domain and range. My domain for this function. You notice it starts here and just goes to the right forever. So my domain would be x greater than equals 0. Let's get my range now. My range, the lowest point is here, and this thing just keeps on rising. Okay? My lowest point was at 0, negative 1. Let me write that in here. So my lowest point's at negative 1, and this thing rose, so y greater than equal negative 1. There's my domain and range. Okay, let me write two sentences comparing these two now. And again, I'm writing two sentences here. Both functions open the same because a is 1. So you notice we had an a, 1 out front, so they both are going to look the same. However, y equals the square root of x minus 1 is translated 1 unit down. Okay, let's make sure we're clear why. It's translated 1 unit down because this starts at 0, negative 1, where the parent function starts at 0, 0. So it's just translated 1 unit down from the parent function. So there's two sentences comparing how they open and where they start. Let's have you pause the video and try numbers 2 and 4. I want you to sketch the function, identify the domain and range of the function, and then compare it with the graph of the parent function. So I would actually sketch both and then find the domain and range and then compare it with two sentences. Pause the video and do that. Okay, we're back. So the number 1 that you did, or I'm sorry, number 2 that you did, y equals negative 2 square root of x, should look like the following. There's the parent function. Y equals negative 2 square root of x is the actual function. The domain would be x greater than 0, y less than equals 0. And both functions start at 0, 0, but y equals negative 2 square root of x is a reflection and stretch compared to the parent function. That would be everything for question 2. Question 4, we wanted to sketch both functions, which you see here. And you see I labeled some points. I always, on my quizzes and things, I'll always have you label the starting point and 2 other points, so you can see that here. The domain of the function y equals square root of x plus 3. The x values are always 0 or greater, but the y values are always 3 or greater, so x greater than equals 0, y greater than equal 3. And then both functions open the same as a equals 1. So in other words, they're both going to open the same because a is equal to 1. Okay? And then y equals square root of x plus 3 is translated 3 units above the parent function. So there I've compared both. Okay? Let's do one more and we're going to shut down the video here. We want to sketch this function, y equals 2 square root of x plus 4 minus 1. Now notice they only asked me to sketch this. We don't have to find the domain and range or compare. So we're just sketching that. So xy axis first. Now I did put the parent function again, but I didn't have to. Now do you notice, let me get out my highlighter, do you notice the starting point for this has to be negative 4, negative 1. Remember, what you see in here is backwards from what it looks like. So there's my starting point. So I'm estimating 4 left, 1 down. Because a is 2, that means this is going to be stretched compared to the parent function, which is why I'm making it look like it's opening more rapidly, or it's opening higher. Okay? I need 2 other points. Now this is an area we do have to be careful about. We need 2 other points. Alright? I want a number in the radical that's going to be a perfect square. My first perfect square is 1. Because the square root of 1 is easy to figure out. It's 1. So I need to plug a number in for x that will make x plus 4 equal 1. So here we go with the mental math again. If you plug in negative 3 plus 4 is 1, and the square root of 1 would be 1, and 2 times 1 is 2, and 2 minus the 1 is 1. So there's 1 point, and you can see it, negative 3, 1. My next perfect square after 1 is 4. I want this underneath the radical to equal 4. Well, what can I plug in to make it 4? Well, I can plug in 0. 0 plus 4 is 4. The square root of 4 is 2. 2 times the 2 is 4, and 4 minus the 1 is 3. And there's another point. So I have 3 points labeled now. I have my starting point and 2 others. Okay? I didn't even need, in this question, to write the domain and range. Actually, I didn't even need to put the parent function either. They didn't ask me to, but there would be a sketch. Starting point and 2 other points. Okay? And then to wrap things up, when you do the story problems you can use your calculator for, and you'll see here in this question, they give you a function where x is the number of years since 1988, and they say, and this is why I wanted just to make sure you saw this on the video, they ask you to graph the function on a graphing calculator. That means you don't have to put it on paper, you just got to type the equation in your calculator. You type in the y equals 93 square root x plus 2.2. In what year were microphone sales about 325 million? Well, look what they do. They said they use the trace feature. You can just take your calculator and hit your arrow keys, and you'll see the little tracer pop up. And you can trace this thing to see in what year were the sales about 325 million. So what you'll find, if you put this in your calculator, maybe you should stop the video and do it, and you trace it, you will see that when x is about 10, y is about 325 million, so the answer is about 325 million. Okay? I'm going to pause the video here. If you have questions, ask in class.